Thank you. As it was said, my name is Sonja Harris, and while I share the last name of this lovely location, I am not related, though my grandfather and father did sell feeders to the stockyards here. I was informed of last night. So, one of the things we've talked about is broadband and definitions of it and different technologies. So I'd like to use the analogy we have of the road system to talk about what each of these technologies are. So if we think about fiber, that's your interstates, your main highways. Go to fixed wireless, we're talking local roads or oiled standard roads. When we talk about satellite, we're talking about a dirt road that's been graded. When we talk about dial-up, you're talking about a cow path. So think of those things and what you can move across those different surfaces, those different foundations, as a good analogy to understand what we're trying to do here. So my company does fixed wireless internet. We operate from San Andreas to Mariposa in the foothills here, and then from Oakdale up to Strawberry. So we aren't the local provider here, but we do have insights of what the local providers here and what you guys can put in place. So as you can see, fixed wireless, we use fiber at a tower to shoot to a network of local towers that then shoots to the home. And so it's all line of sight, which is always fun when you get in hills and valleys. So, and it uses radio frequencies. Those frequencies are 2.4, 5.8, 900, just a spectrum of things. And again, think what's happening in your Wi-Fi router. Most of you have a dual band Wi-Fi router. That's 2.4, 5.8. Same frequencies we're talking about here. So we use different technologies. If we could move to the next page. Thank you. This is the equipment we use. We do a lot of testing in our area, and these are the brands that we use that we've tested. And these are the ones that we put on towers. So this is a tower that my company has built, and on it you can see these dishes, these sectors, these different things. This is a local neighborhood tower that serves the city of township, small municipality of Groveland, California. And it barely covers that. And it is fully loaded. Every single spectrum available to us is on this tower so we can serve that community. We consider that community fully served at a 30% penetration rate. That means of the example, 100% of customers potentially there, if we achieve 30% of them, I consider that town fully served and will no longer do any advertising other than to make sure we know who our customers are and that they refer us to anybody else in the neighborhood. Now, part of that is due to people's adoption. Some only are retired, do not care about internet, have never had a computer, don't want it. But when we're talking about 70% of the population, there are other options. They're using dial-up, they're using satellite service, and they're using local community centers to achieve that. So let's see. With our system design on this, there are two specific things that we do that I think makes our network really solid. We use redundancy. Every single tower is fed by at least 2 towers. Every single network access, our fiber lines, come from 2 different service areas. So we shoot one large fiber up from the valley, and we have another one that's a direct fiber that comes up directly to one of our towers. So what that means is if something happens, like it did on Tuesday, where level 3 had a huge outage that took out part of the Bay Area, part of Sacramento, we were not affected because our southern part of our network was fed from a different source. So we can run the entire network in one of those 2 ways. The other thing we believe in is 4 hops, and this is critical for your area as well. At each spot, when you go from a home to a local tower that's probably just on the hillside above that little valley, to a larger tower, to fiber, each one loses something as far as, think of it as the same efficiency photosynthesis has. Sun down to a plant, plant to an animal. We only get a percentage of that when we then eat that animal. Same idea. So we stick under a 4-hop rule, which can make things complicated. And it changes the cost of things. So one of the things that we do, if you would go to the next slide, please, is just talking about the advantages and disadvantages of this technology. As we said, we're that oiled road. We aren't the highway. But if you've put it in a highway, you know it has a big cost. The longer the road is, the more expensive it is. The rule we use whenever we have to run fiber is $10,000 pole to pole, because we don't bury it in our community. $10,000 each swing of the pole. That's incredibly expensive when you need to go to a farm that's down a mile driveway. So one of the things when we can shoot from here to there, a mile is nothing. I think our longest shot is about 70 miles. We try to stay within a 20-mile surface in any point-to-point system. So weather does not affect us except in 2 cases. A storm, where it takes out power at a tower from a tree, and hopefully our battery backups and solar will cover for that, or true winds that knock out the alignment of something, and lightning, which is just evil. Because it strikes a tower, and even a grounding, we had one this year that actually blew apart the base about 100 feet. It was a fun one. So, and then fast, quote-unquote, fast deployment. I can go, once I have that tower up, anybody that can see it, all it takes is my 2 guys to go out there and hook it up. That's fast compared to running fiber and fiber. Disadvantages is once again that spectrum. Everything we're talking about as far as what's on a farm, what is in the field, what's happening at the tractor, most likely is operating on a 2.4 spectrum. And think about it as your FM or AM radio. Each channel, there are only so many channels that you can listen to in there. And there's bleed between them. That's why we jump in, 2 channel increments. 105.1, 105.3. And what's happening there is, so your devices within the farm are talking to each other on those spectrums. So all of a sudden that's out. I can't serve that farm at all with that because it's just going to interfere and nothing's going to work. So from the tower itself to the home of this unit, I have to be very careful as to which spectrums you can use. The more providers you get in there on those, once again, you're cutting up that spectrum. The other thing is the higher cost. Think of each time you run a truck on a gravel road. It has more wear and tear on that truck than it would on a freeway. That cost to run that through those technologies is more expensive than running it, down a highway. And so it does have a higher cost, and there is a limit to how much you can move there. Right now, the technology is constantly shifting, but the most I can do today is 100 megs, which in my book is really impressive, but it comes at a cost of $4,000 a month. Most farms aren't going to want to take that, but most farms don't actually need that $4,000. Most of our large farms, Rosasco Ranch, Diestel Turkey, which you've probably heard of, Indigenous Cider, they're operating on a 50 meg package. Diestel Turkey, that's for each of, that's split between their 3 main facilities and then to each of their grow houses. And then line of sight is the other big disadvantage of this technology. If we can't see you, you can't get service. Now, sometimes for, say, a mining operation, there's a hilltop. We can put a little tower up on the hilltop and we can see the hilltop. And then we can do a bounce of another technology down. Once we get back to that 4-hop rule, now I'm at a 3-hop rule for that location. So each of these does have advantages and disadvantages, but sometimes a gravel road is far better than a cow path.